Today, we're going on a bit of a microscopic journey. Think of it like a medical mystery. We're going to learn how to read something called a peripheral blood smear, and in doing so, uncover the incredible story our blood is trying to tell us. It's a story that goes way beyond just simple numbers, so let's dive in.
So let me just start with this question. What if your blood could actually talk? What kind of stories would it tell? Well, believe it or not, it kind of can. A blood smear is like taking a snapshot of a super busy city filled with millions of cells, and every single one has its own job, its own shape, and its own story. And today, we're going to be the detectives who learn to read those stories.
So our investigation really begins when we decide to move past just the numbers. We're going to shift our thinking from basic counts to looking for visual clues. The kind of evidence that can crack a case wide open.
Okay, this slide right here gets to the heart of it. Most of us have probably heard of a complete blood count, or a CBC. That report gives you the numbers. It tells you how many cells you have. But a peripheral smear, that's a whole different game. It's a visual inspection. It actually shows you what the cells look like, their shape, their size, their color. And that is where the real detective work begins.
First up in our investigation are the red blood cells. You can think of these as the body's busiest messengers, right? They're constantly zipping around delivering oxygen. And because there are so many of them, they often give us our first and most obvious clues.
So our first clue has this really fancy name: hypochromic microcytic cells. I know, it's a mouthful, but all it really means is that under the microscope, the red blood cells look kind of small and pale. It's like they've lost some of their normal, healthy red color. So, what does a clue like this tell us?
And boom, here's the answer. When a pathologist sees these small, pale cells, it's a classic textbook sign of iron deficiency. The body just doesn't have enough iron to make those healthy, hemoglobin-packed red blood cells. Just like that, our first major clue is solved.
Okay, let's move on to our next piece of evidence: Macro-ovalocytes. Now, these cells are basically the complete opposite of our last clue. Instead of being small, they're unusually large, and they have this distinct oval shape instead of being a nice round disc. It's another one of those very specific visual clues.
So, what's the story here? Well, these large oval cells are a huge pointer towards a vitamin B12 deficiency. See, the body needs B12 so its cells can divide properly. Without it, the red blood cells just get bigger and bigger and end up misshapen. It's another mystery we can solve just by looking at the shape of the cells.
Now, sometimes the clues we find aren't just subtle hints. Sometimes they are screaming red alarms.
And that brings us to schistocytes. Just look at that description: fragmented, helmet-shaped cell fragments. These aren't even whole cells anymore. They're the broken, shattered pieces of red blood cells that have been violently ripped apart. This is a very, very serious clue.
And here's why it's so serious. Schistocytes are direct evidence of something called hemolysis, which means red blood cells are literally being destroyed inside the body. This isn't some deficiency. It's an active, ongoing, destructive process, and it signals a true medical emergency. Finding these cells can literally be life-saving.
All right, let's switch gears in our investigation. We've looked at the messengers. Now it's time to question the police force, the white blood cells. These guys are the immune system's first responders, and their appearance tells us a ton about the kinds of battles they're fighting.
Our first white cell suspect is the hypersegmented neutrophil. Normally, the nucleus of this type of cell has, 3 to 5 connected parts, or lobes. But our clue here is when we see a neutrophil with more than 5 lobes. It just looks overworked, almost overcomplicated.
And what does this tell us? Well, it's another classic sign of a B12 or a folate deficiency. And what's really cool here is that this clue can actually confirm what we might have already suspected from seeing those large oval red cells. The evidence is starting to stack up, and it's painting a much clearer picture.
Next up for questioning are the atypical lymphocytes. Now, lymphocytes are another key type of immune cell. But when they become atypical, they look big, irregular, kind of angry actually. They are clearly activated and in the middle of a big fight. But a fight against what?
This specific look is really strong evidence of a viral infection. These are the cells on the front lines, battling viruses like dengue or Epstein-Barr virus. That's the one that causes mono. Seeing these cells tells the doctor exactly what kind of enemy the body is dealing with.
Okay, we've reached the final stage of our investigation: the platelet puzzle. Platelets are these tiny little cell fragments that help us clot, but don't let their size fool you.
they hold some crucial evidence too. Let's analyze these last few pieces. We've got two really important clues here. First, seeing giant platelets can actually be fantastic news, especially if someone is recovering from an infection, like dengue. It means the bone marrow is kicking into high gear, pumping out fresh new platelets. But then you have platelet clumping. Now this one is a curveball. It's when platelets stick together in the test tube, so the counting machine can't see them properly. This can create a scary-looking false low number on a report, which is a perfect example of why having a human eye look at the actual smear is so critical.
So now it's time to put it all together. Let's see how all of these different visual clues combine to solve the medical mystery and help us land on a final, really accurate diagnosis.
It's really a clear, logical process when you break it down. You start with the numbers, the quantitative data from the CBC. Then you dive into the real evidence. You investigate the red cells, you question the white cells, and you analyze the platelets. Each step builds on the last one, allowing a doctor to form a complete and confident diagnosis.
If there's one thing to take away from all of this, it's this quote right here. The numbers tell you something is happening. The shapes tell you why. The lab report numbers are the starting point for sure, but the visual story that you see on the smear, that is what gives you a true understanding of the whole picture.
And that kind of leaves us with one last thought. We just uncovered the hidden language of our own blood cells. It makes you wonder, doesn't it? What other vital, maybe even life-saving stories are all around us, just hiding in plain sight, waiting for a curious mind to look a little bit closer and learn how to read them. Thanks for joining me on this one.